Hi friends, welcome to WafaStudies YouTube channel. This is continuation to the Fabric playlist. In this video, we will be discussing about working with data using the Spark SQL. So inside a Spark, you can actually use the SQL language capabilities, SQL expressions to query and manipulate data. So that is possible using the Spark SQL API, which is available inside a Spark. So that means literally, if you have a data, you can use the SQL capabilities. You like how you write a SQL queries, you can do that part. Okay. So let's discuss about creating a database objects. That means what I mean is, so when you want to write a SQL queries, you need to have either tables or views, right? So those are like a database objects. So before using this Spark SQL, you need to create those database objects. That means either views or tables in Spark catalog. So what that means is, assume that Spark catalog is like it's like a container, a holder inside the entire Spark framework. So in that Spark catalog, whenever you create any table or view, it will get placed there. Okay, and this Spark catalog actually helps you to use the Spark SQL to write the SQL expressions there, and use your SQL capabilities for the data analysis. Okay, so as you can see here, uh, generally from my previous video, you know that we take the data from the files into the data frame first. So once you take the data into the data frames, you can use this create or replace temp view function that will actually create a temporary view which will live for the current section. So session, right? If you are running a notebook, that is called the current session. So within that session, it will create a temporary view, and once you have that temporary view, you can use a SQL on top of it to query that information. Okay, and this view, whatever you create, it will be placed in the Spark catalog. So everything is in a Spark catalog. Okay, so not only that, if you can also create something called tables inside the Spark catalog, and these tables are not like a views. So views will get destroyed once the session over, but tables are persisted in catalog, so that will be live always there. And these tables will be appear in the lakehouse of the Spark, sorry, Fabric, and the underlying data will be actually in the underlying storage locations. Okay, so but for you in a lakehouse, it will appear as a table. Okay, and you can create something called external tables also. So what external tables means is, you will be having a table, and that table data will actually refer to some external storage. So maybe let's say you have a data in files folder, a file, CSV file maybe. So that data you can refer it using a external table. So external table is like a only a metadata. Data will be somewhere in some external location. It will be a metadata layer on top of it. So if you delete this external table, the data will be still remain there because it's a external storage data. But if you delete the normal table which you created in a Spark catalog, which is called nothing but like a managed tables, then the underlying data will also get deleted because it is like a literally like a table. Okay, so let's see all this practically and understand. So let me go to the browser. So this is my workspace. In this workspace, if you remember, we have this sample lakehouse from our previous videos. Okay, and if you see here, there are some tables also created, right? This was I was trying, so it got created. So let me refresh this here just to make sure these are the tables we have. Now on top of that, we will create more tables now. Okay, these are like a database objects, like tables or views, whatever we create. Those are like a database objects using which we can use a Spark SQL there. Okay. So now let's do one thing. So let's go back to our workspace and let's open this notebook which we were practicing from our previous video, notebook 3. So in this notebook, right? So if you remember, we were actually we written some code to read a file information and then create a data frame out of it in our previous videos. If you see here, right, products.csv file is available inside the files slash data folder. So I can show you that. So if I go to my lakehouse, and here under the data folder, and I can see there is a products.csv file. You see that? So it is under the data folder, right? So that file we pointed and we created a data frame in our previous videos. So let me click that and open that. You see we have product ID, product name, category, list price, and we have around 10 rows. So this piece of code which we tried in our previous video, Spark read.load, take that file and CSV format header true because the first row is the column names. So this will actually create a data frame. So let me run this command once again, shift enter and show the results. So shift enter key will help you to run this command, and you can see that it is running a command there. Okay, so let's wait for the command to run. You can see that command is running, and once command runs successful, it will show you the results also below the cell actually. So right now it is running this cell. Okay, so let's wait for the execution to complete here. Yes, you can see that now it gave the entire table, but now the table is loaded into this data frame. So now what I wanted to do, so take this data frame and create a database object like a temporary view as I shown in the OneNote. You see that create or replace temp view. So let's create that temporary view. Let's create this temporary view now and see how that will behave. Well, will that allow us to do the SQL part, whether we can write a SQL queries or not. So what I will do here below, right, I will add one more code cell. Okay, so then here I will be, what is my data frame name? So let me take prd underscore data frame. Okay, dot create or replace temp view, and I will name it like a temp view. So that is the name I wanted to give. So let me hit shift enter to run this cell, and if you see here, this cell execution is successful. It's already executed. Now what I will be doing it, I will add one more cell here, and this time I wanted to write a SQL on top of this view to see whether we got the data in a view or not. So I will switch to SQL by entering this magic command percentage SQL. The moment I does that, you see that the cell was pointing to the Spark SQL, but the previous cell was pointing to the PySpark because I am writing a PySpark code there. But using this magic command, I am pointing to the Spark SQL now. So now I can write a SQL code there. Maybe here select star from the view which I created, which is temp view. So let me hit shift enter to run this cell. You see this cell is executing it here, and you see it is completed also. And in our temp view, I have the data to here, right? I hope you make sense, right? This is a query and this is the data. So that means I'm able to create a view, and then I'm able to use a Spark SQL there. Okay, this is one thing. And second thing is there is one command called, everything is in a catalog, right? So if you see here, spark.catalog.create table, for any reason, if you want to create a empty table, table means which it will not go away with the current session, it will be always available for you until you delete, right? So if you want to create by any chance an empty table, just a table with a column names and all, then you can use spark.catalog.create table method, and that's what it is described here. If you see here, spark.catalog.create table, then we are giving a table name, and for the table we have to have the schema, right, column names and data types. So that's what we have defined here using the structure type, like how we did in a previous class, and we just use it the same thing as a schema for the table. So this actually creates a table, but it will be a empty table. So let's try to do that. So what I will be doing is going back to my, so select star from, so here I will add one more cell. So what I will do here is, so first I have to import few libraries, PySpark dot SQL dot types that will hold all the data types. So let me import all types. Then from PySpark dot SQL dot functions, so let me import all the functions. Okay. So because structure type I have to create using a structure field class, so I should have that. Then let's say maybe table schema equals to, let me create a structure type constructor object. Okay, so to this I have to use an array, and in array I can use structure field, right? So I can use a structure field here, and to the structure field I can give a name, maybe id column. Then it may be integer type, so I can tell that it's an integer type column. Then once again structure type, sorry, structure field, Then this time maybe I want to name it like a name column. Then this may be string type, right? So I can do that. So once I have this table schema, now I can try to create an empty table using Spark dot catalog dot create table function. And to this function, if you see the intelligence, I have to give the table name and also I can give schema too. So let me do that. So for the table name, I want to name it like maybe Mahir empty table. Okay. Then schema, I can use a schema. So for the schema, I can pass my table schema variable value, which is a structure type. So now if I execute this, it should create an empty table. So let me run that. And if you see, my cell is running here. Okay. So let's wait for the cell executions to complete. And once see, it seems the cell is still executing. So let's wait for it to complete. Cell execution completed. Now I can show you this table. If I go to my lake house, right, and if I refresh this tables folder here, I should see that Mahir empty table too. You see that? You see that? So we see that table, right? So it's an empty table basically. We don't have any data there. So to prove you that, what I can do, I can use the table name once again. My table name is Mahir empty table. Let me copy and let me use it here, right? The SQL command, the magic command we have already used. So let me say select star from that table. And when I run this time it should give a empty, right? It should just give you the column names. You see that there is no data there. Okay. So this is like a empty table which we created it. So now we can also create an external tables. So what I mean by that is, if I go to here, right, in the same spark.catalog, there is a function called create external table. Here in this case, it will actually point to the data which is there in some file in some external location. For example, if you see this Spark catalog.create external table, I gave a name to the external table, but I'm pointing to this location. Okay, that means the data is here, and on top of the data, I'm creating this external table, and I'm telling it's a CSV file and what is the schema for that file data. So I defined like similar kind of a table schema, and then I created it. So in this case, if somebody drops this table, deletes this table, then this file will not get deleted. So because data is external, so it will be always available. Only the table will get deleted. So that is the reason external tables are like a just like a metadata. Okay, so it's like just like a metadata kept there, but actual data is somewhere else, and the actual data will never get deleted. Okay, so I think I have an example for that. I have already written the example for that. Let me show you that. So if I scroll down, so I tried that code already. Let's see here. You see that. So what I am doing it here. So I am using a structure type and structure field and defining the schema for the data in a file. And my file is products1.csv. This file is there in the files and data folder. So I can show you that. If I go to the lakehouse, if I go to the data folder, files and data folder, so let me go back to the files and data folder. You see that here I have the products1.csv file. And if I open this file, I don't have any header columns there. That means all the rows are like a actual data. So there is no column names if you observe here. So that is the reason I want to define the schema also for it. So that's what I was doing in my notebook. So if you see here, we are defining a schema for the data and passing that schema to here and telling that source is a CSV file, and we gave a path and this is the external table name. So let me say this TBL products 1, and if I run this, it should create an external table. So let's run this and let's examine whether it created an external table or not. See, command executed successfully. If I go back to Lakehouse, I should see TBL products 1 actually. So let me refresh these tables. So I see that TBL products 1, and I can also execute a select query on top of that to see whether I have data or not. So let me execute a query here by writing select star from TBL products 1. So let me run this cell and I should see the data also from the external table. You see that I'm able to see the data also here. Okay. So let me go back to my OneNote. And one more thing, let's assume you have a data frame. Now you want to write that as a table. So how to do that? So for that I can use this data frame dot write dot format delta save as table, then mention the table name. So I can do that. So let me do that now. So let me go back to my notebook, and in the first cell we have created this data frame, right? So we have created this data frame. So let me do one thing. So let me click here and let me take this data frame, right, which is there here. So let me take this data frame and write that as a table. So data frame dot write dot, now I can use a format and I can mention it as a delta. Okay, so delta format, then save as table. So when I use save as table, I can give a name. So I can say like Mahir PRD. So that's the table name I want to give. And now if I run this cell, it will actually create a table with this name using this data frame. Okay, so let's see that. So let's wait for the command to execute here. So command execution successful. If I go to the lake house and if I refresh tables, I should see that Mahir product table. You see Mahir product table is there. And also if I go back to notebook, I can query that Mahir PRD table as well. So let me take this, and here let me use select star from Mahir PRD table, and if I run this cell here, and I should see some output here. You see that I am seeing an output here. Okay, so let me go back to my OneNote. So I think I have covered pretty much, and I want to cover one more thing. So the Spark SQL can be used using this SQL function also. So inside a SQL function, you can use your SQL expressions as strings, and that will do the job. So previously I used these SQL expressions using the SQL magic command. So I changed the language to the SQL. But now let's assume you want to continue the PySpark, but still you want to use a SQL expression. Then use the SQL function and give your query as an expression there in a string format. So that will do the job. So let me try this. So if I go back to my, so here, right, so I want to execute the same query, but I don't want to execute using a Spark SQL. So I want to execute using a PySpark. So let me do one thing. So let me remove this magic command. Then I will say spark.sql. Then in double quotes, I can take this query, and the output of the query will store in a data frame. So I will name it like a df. Then I will try to display the data frame for my reference to see whether it works or not. So now if I run this, you can see the same result. So you see that I got the table data here back, but SQL expression I have used as a string in the PySpark code using this SQL function. So that's the idea I wanted to give. Okay. So let me go back to my OneNote, and this SQL code part, you know that. So use this percentage SQL magic command, and that will do your job. So your notebook points to the SQL language in that case and directly use a SQL expression. So I hope you enjoyed this video. Thank you for watching this video. I hope now you feel comfortable working with a Spark SQL in the Fabric. So stay tuned for the next video. Thank you. Have a nice day.